Let's look at another form of muscle adaptation, or length changes to the muscle. And there is some basic science as well as some applied evidence that we can have a length change in our muscles, either a shortening or a lengthening. And that length change is due to adding or getting rid of sarcomeres. And remember, the key sensory mechanism, or the key mechanism of this change, is the sarcomere length. And remember, the sarcomere does not like being short. It can, in a scrunched position, it cannot generate as much force. It does not like being in a lengthened position where it also cannot generate force. So the sarcomere is always trying to hit that 2 to 2.5 microns. Okay, so let's look at some data from these studies. And these were done on animals. And so what they did is they either put rats in a chronically stretched position, meaning that they took probably their hind limb and they were looking at the gastroc soleus. So if you have a hind limb, here's your ankle, and here's your gastroc soleus. And they basically put this ankle joint into dorsiflexion, which applied a stretch on the gastroc soleus. And after a chronic stretch over a certain amount of time, they found an increase in sarcomere number by 20%. So after a while, there were 20% more sarcomeres. And just keep in mind that in order to make these measurements, you have to actually dissect out the animal and look at each individual sarcomere and how many sarcomeres are in series. Then they also took some animals, here's our ankle joint again, and put them into plantar flexion, which basically chronically shortens the gastroc soleus. And after a period of time, they found a decreased sarcomere number by 40%. So here's our first key comparison between lengthening stimulus and shortening stimulus, that if you shorten a muscle, that is a greater stimulus than if you lengthen a muscle. And keep that in mind when we're looking at our outcomes for flexibility programs. A few other things to keep in mind. These sarcomeres are typically added at the musculotendinous junction, and typically anti-gravity muscles, quadriceps, gastroc soleus, hamstrings, mainly being anti-gravity at the hip joint, are most adaptable. Another thing to keep in mind is, let's go to another slide. Let's get rid of this. There is a big age effect. Young animals, when they were in a lengthened posture, they would have actually a shorter muscle fiber. So there was actually a decrease in sarcomere number, which is odd, which is completely opposed to what I just told you. But remember, these are young, growing animals. But their length increase occurred at the tendon. So we want to think about, do you want individuals with a shortened, active part of their muscle with longer tendons, or do you want a longer muscle belly that you have control over, voluntary control over, with shorter tendons? So keep that in mind when we talk about training young gymnasts, young ballet dancers, young dancers in general, what the long-term result may be of increasing their range of motion through lengthening exercises. However, there is an advantage of being older, because after a lengthening stimulus, we do get an increased muscle fiber length. So flexibility exercises do actually have an effect on older populations.